Good afternoon and welcome to today's webinar from TDUK. Today we're going to hear from the creators of Howden Hall Road. That's Robert Hairstans from Edinburgh University, architect Grigor Mitchell from Grigor Mitchell Architects, and Matt Stevenson from Ecosystems Technologies. But just before we get started, I'm going to say a few words about Timber Development UK. We were formed in 2021 from the merger of TRADA and the Timber Trade Federation, the TTF. Bringing those two associations together has made us the largest trade body in the UK. Here you can see some of our various publications. There's Designing Timber. Designing Timber and Supplying Timber are our two flagship magazines, fulfilling the needs of the design audience and the supply audience, packed with inspiring timber buildings. You can also see one of our examples of publications from our packed knowledge library. That's moisture. Excuse me for a second. My computer's playing up. That's moisture management during construction. Excellent document, well worth downloading. For example, there using structural insulated panels. That's an example of one of our knowledge sheets from our knowledge library. And next to that, you can see one of the many case studies that you'll find on our website. So TDUK members can access case studies of all sorts of building typologies, fantastic buildings, all constructed using timber. There are three mission statements to connect the supply chain, lead best practice, and accelerate a low carbon future. Another output of ours, which helps us to do that, are the Wood Awards, which we work closely with the Wood Awards. You can see the latest issue of Designing Timber magazine was a Wood Awards special covering all the winners of the Wood Awards 2025. Many of our resources are open to all, so do have a browse around our website, but there is a substantial amount of very valuable member-only content. We'd love you to join us if you're not a member. It helps us to put on fantastic webinars like this one. It helps to amplify the voice of anyone working with wood in the UK. You can find out more on our site, or you could contact us if you have any questions, info@timberdevelopment.uk, or give us a call. So yes, now I'm going to hand over to Robert. Oh, just before I do that, a little bit of housekeeping. At the bottom, you should find a Q&A box. Please do type in questions for the panel. We should have about 10-15 minutes at the end to answer your questions, but do type in questions as we go along. We might answer some of them during the course of the webinar, save some for the end. But yes, I'm going to hand over now to Robert. If you'd like to start sharing your screen. Thank you.
Okay. I should now be sharing, I hope.
Yep, can see that fine.
Perfect. Excellent. Okay. Thanks very much, Matthew, and indeed to Timber Development UK for hosting this webinar this afternoon. This is a project, Timber Modern Methods of Construction Retrofit project, a living lab case study, which I'm the client to as the homeowner, and it's been a collaborative effort over a number of years to essentially trial and test a series of research and innovation projects into my own home, and to take the lessons learned from that, and of course correspondingly leveraging a whole series of funding arrangements. So you can see some of the partners and some of the funding initiatives we've used predominantly to gather research intelligence. So the objectives of it really, from a personal point of view, was to learn about the whole process, and to do that from home purchase in 2011 and integrate the findings of our live and research work into that, measure and monitor the impact of it with an emphasis on the sort of whole life value impact, and we'll cover some aspects of that with regards to the environmental credentials and look at the operational performance and equally what that means from a financial perspective. And in many regards to trial and test, as I say, these timber technologies, there's a vast array of which to validate the proof of concept of them, because as the client in this respect, I had the capability of doing so. So just a small of sort of background and to go through the phases of the project. I mean, this was the house when we bought it in 2011. The sort of Scottish approach to offers around as it was at the time. The purchase price I think we got it for was 247,000, and it was in a pretty dilapidated state, as you can see. So correspondingly, we took that on and recognising that we were going to have to do quite a major overhaul to it. And the first thing we did indeed was go in and rip out the carpets and tear down the wallpaper and do all of that stuff. And equally looking at the sort of footprint of it, recognised that there was potential in the project, huge potential, because of the size of the plot that it sat on and the opportunity that resides within a bungalow, with respect to, you can reconfigure it because of the nature of the roof structure, and at that time as well, the attic hadn't been converted, and the existing sort of extensions that had been undertaken in terms of a sunroom were in a pretty poor state. So we just recognised there was a whole bunch of work that we wanted to do. I mean, just to cover that part of the project, there is a sort of short animation, which we wouldn't have full time to go through today because of the time limitations of this, but it's to give a sense of some of the project partners that were involved, and indeed from the original home report, where it was with regards to energy performance. As I say, we looked at the project in itself and recognised that we could reconfigure the internals and remove the walls, working with the architect at the time, and we essentially set about doing that in the first instance. We looked at the installation of cavity wall insulation and the sort of general upgrade of the property, including, incorporating new windows and doors. What we then looked at was ways and means of extending the property, and at the time we were working with Access Technology, and we came up with an innovative concept of, rather than having to put a foundation in, could we create a coil glulam beams because of their high durability and strength and stiffness, and use that to cantilever an extension off. And equally, with regards to the sunroom that was there, we could use the existing footprint of that, reinforce it, and then manufacture off-site engineered timber products in terms of glulam beams to install those to support the roof structure, and equally off-site fabricated panels with a high level of insulation, so closed panel systems, which we did. And then correspondingly, we brought those to site, and using a sort of forklift truck that we could get round to the rear of the property, we installed those, and then we followed some principles to make sure they were highly insulated and equally had a high degree of air tightness. With it being a living lab, we want to measure and monitor the performance of those, predominantly from a structural perspective. So we incorporated dial gauges to measure the instantaneous and long-term deflection of the coil glulam beams. So we did all of that, and then finished it off, and then, as we suspected, the beams were outperforming the intended requirements, and the allowable deflection was well within constraints, which was important because of the glazed units that were going into that, and we didn't want any movement which would obviously have an impact upon the seals of the windows, etc. And then, of course, we enhanced the overall energy performance of the project in itself, and that's what it looked like at the time that we finished that phase of the project. And other things that we did was incorporate renewable technologies and a 10-panel solar PV array at 2.5 kilowatts to reduce the energy consumption of the property as well. And another thing that we did was the first use case of Scotch pine Accoya cladding on the sunroom as well, to try and test that, to see how that got on. So that was like the first phase, and then after a number of years, we determined that we wanted to extend the property further, and in 2021 to 2023 we went about doing that, and that converged at the time with a transforming timber project that we'd secured, which was led by Built Environment Smarter Transformation, taking the research work of Edinburgh University into homegrown timber and how that could be manufactured into engineered timber products with an emphasis on mass timber construction, cross-laminated timber, nail-laminated timber, and glue-laminated timber, and through ecosystems technologies, how those products could be scaled up into the market. So the emphasis of that was, as shown, to look at how to essentially improve the environmental credentials of construction and built environment delivery using UK homegrown resource, and to demonstrate that into a series of living lab projects which we could measure and monitor. So again, take on the role as a client, sort of main contractor in many respects, but equally through a very collaborative procurement process, working closely with ecosystems and BEST and a number of others, looking at how we could incorporate the products that we were essentially taking our research work and ultimately having commercialized via BEST, and incorporate that into a series of live projects, including my own home. So that's where this Transforming Timber retrofit project came about, and the products at the time, we'd obviously done a lot of structural test work and quality assurance work, and then it was about essentially implementing into this live project. So Grigor Mitchell Architects was who I engaged with in this instance, and Grigor's on the webinar today. So again, through that collaborative procurement model, we looked at the planning and building regulatory constraints of the project, and Grigor will go through in more detail how that informed the shape and form of it, but we had to consider such things as the ridge height of the existing building and the proximity to neighbour with respect to the cladding that would be applied. So in this instance, we used zinc cladding for those good reasons, and we looked at the shape and form of the building to match in with the planning requirements of the area. And we also took cognizance of the plot and the access to the plot, and that informed the sort of, you know, the form of the project itself with respect to the sort of design for manufacturing assembly. Because through that collaborative procurement model, we were able to engage and understand what could be manufactured and how that could be used for the delivery. Grigor's a Passive House qualified architectural practice, and the principles of that were certainly considered and utilised with regards to how the products were detailed for airtightness, reduced thermal bridging, and high levels of insulating properties, as well as, I say, considering the design for manufacture and assembly. So Grigor will cover that in more detail, but one of the things that obviously allowed us to do, and we were able to leverage our digital technologies, which we have through our Trimble Technology Lab, was to think about the DFME approach to digitally analyse the site in itself, and correspondingly think about closely how the panels could therefore be manufactured within the capabilities of the facility at BEST, which ecosystems operate out of. So correspondingly, we created a series of fabrication drawings for the CLT, and then thought about readily the high levels of pre-manufactured value add that we could do. So in this instance, we therefore looked at how much we could incorporate the windows and doors, the external and internal lining, as well as the insulation and the external fixtures and fittings as well, to streamline the approach on site. And as I say, we worked on a very collaborative basis to the extent of engaging early with the zinc supplier, such that the zinc work, as much as possible, was installed within the factory environment. So that all took place. We obviously had to think about how to load that up onto the articulated lorries for delivery, and it was all held at BEST, a short journey along the M8 in Glasgow from Edinburgh, and we obviously got consent from the neighbours to utilise their space for some of the installation, and obviously had to think about the utilisation of a crane in our drive to install the panels. And ultimately this took place in January, so it was in mid-January this took place. So obviously weather conditions were a given constraint, and obviously the time within the day of daylight. So it had to be undertaken quickly and smoothly, and ultimately it was undertaken over the course of one weekend to get it installed. With regards to this being a biogenic response, and thinking about not just the timber technology, but other environmental appropriate products as well, we looked at obviously enhancing the existing fabric of the building, and at the time we used a cork saw render product to do so, and that's a sprayed on cork and product, a render finish, which doesn't give you higher levels of insulation properties, but what it does is it obviously provides weather protection, and it's a breathable material, which was therefore also applied to the existing building to enhance its aesthetic, improve its durability, but do so without having a high impact from an embodied energy, embodied carbon perspective also. So we took that into consideration. So you can see this is now the sort of finished article in many respects. The form of it has obviously been shaped by how we've had to leverage finance, the technologies that we've integrated, and what we've learned over the course of the project in itself. And you can see the external aesthetic. The cladding has some, weathering, but there's no rot or anything like that on the cladding. That's just the aesthetic, and in fact we're coming round the full cycle now where we'll have to go over that and re-enhance it from an aesthetic perspective, but that's all fine. We've obviously got a high level of light and solar gain that comes into the property because the garden is southwest facing, so that's obviously enhanced the internal feel of it from an occupational perspective. You can see here the area that I'm sitting in currently. We've finished and internally lined it with timber products and system as much as possible, and equally in the new kitchen area we've left the CLT and the nail laminated timber ceiling fully exposed, and wall mounted the electrics, and there's no gas that's going into that area. There's obviously gas in the existing property. It was an existing gas combi boiler, but we've done other such things to try and reduce their operational performance, not just through the photovoltaics, but other such things as incorporating a sun amp thermal heating battery for hot water as we try and decarbonise the property. That just gives you an aesthetic as well of the stair that goes up into the office space. We reused tulip wood for that, which was reclaimed from the multiply project that we were involved with at Edinburgh Napier, and we repurposed that into a stair. So we used reclaimed materials for aspects of the project, including, for example, some of the foundation materials as well. And you can see the front aspect of the new mass timber extension with the zinc cladding there on the right hand side. We've done a whole series of research and analysis of this project, which we wouldn't have the time to go through today. But one of the things we have done is a life cycle analysis, A1 to A4 analysis, and reporting A1 to A4, as well as the embodied energy, the embodied carbon as well, so essentially what's been sequestrated. So you can see in phase one the impact A1 to A4, and then you can see the sequestrated carbon through as a result of the utilisation of timber, both in terms of the engineered timber products, the closed panel timber system, wood fibre insulation that we've used extensively, and also the timber cladding, as well as the introduction of a staircase for access into the attic space, which we manufactured from birch ply. So there's two stairs as it happens within the house. And what you can see in phase two, because of the utilisation of mass timber, there's a lot more sequestrated carbon, and obviously through mass timber, the utilisation of mass timber products, as well as wood fibre insulation also. And additionally, there's some impact there because of the use of Corksol as a render product, as much as that's marginal. And so we've consolidated the environmental product declaration information, and correspondingly we're able to report on the A1 to A4 findings as well as the embodied carbon separately. Overall, we've done a lot more analysis of the project, which we can't fully unpack today, unfortunately. But what I would say is, we have significantly increased the footprint of the dwelling from its original purchase in 2011. We've more than doubled it. As a result of the works undertaken, we've taken something which was in a dilapidated, rundown state, and essentially transformed that asset and increased its value substantially over that period because of the renovations and extension works, which far exceeds what it would have been in terms of pure market valuation if we hadn't done anything to it, beyond the fact that it had become further dilapidated. As much as we have increased the footprint of the building significantly, we have reduced its overall energy consumption by almost 30%, and we're continuing to look at ways and means of improving that yet further. So we've increased or improved the fabric performance of the existing asset. Any of the extension work that we have done, we've followed high levels of insulation and airtightness, and equally, as much as feasibly possible, we've used biogenic or renewable natural capital with an emphasis on timber technologies with respect to those extensions and renovation improvement works. And where possible, also, we've utilised recycled and reclaimed materials to incorporate those into the building also. So as a result, it's had quite a significant impact, and we've obviously been exceptionally fortunate from the point of view of working in close collaboration with a whole series of partners and external collaborators to make that work and utilise a timber offsite modern methods of construction approach and embracing design for manufacture and assembly. So what I would say is, if you want further information on the embodied energy or life cycle analysis work, there's published outputs. If you wish information, for example, on the thermal battery SunAmp technology we've integrated, there's a paper on that. And all of the information and findings are contained within a journal paper, which we've just recently published and was released at the start of this year. And we'll disseminate that information following this webinar, as well as equally the links to the animation content as well, should those wish to see it. At this juncture, I'll hand over to Grigor, who'll go through it in more detail from an architectural perspective.
Thanks very much, Robert. I'm just bringing up the next slideshow. Wait a second. Here we go. Hopefully you can all see that. Can you see that, Grigor?
I can, yes.
Okay.
Apologies, I can't get the share to work, the share screen on my tablet. So I will be saying next between each slide anyway. So yeah, so I'm the architect who was involved with phase 2 of the project. So thank you, Robert. He was a really good client. No other phases of the project were affected by my phase, and no chickens on site were harmed either. So anyway, I'm an architect with my own business. I specialise in passive house and low energy design, new build and retrofit. I'm also a tutor at the University of Edinburgh on the master's programme, and also on the advanced sustainable design course. So when I started in business, I did the second certified passive house designer course in 2010, and I suppose fairly quickly moved on to working on new build passive house projects. What I would say about timber frame technology in Scotland is that it's the norm, really. So there wasn't a big leap to be building timber frame passive houses. At the time, majority in England were using sort of wet trades, using blockwork, etc. But I've got experience of, through the projects I've worked on, there's a few examples of projects over the last 10 years. I've worked on projects with, closed panels, stick build, open panels, hempcrete. Generally, I try and innovate with what I'm doing, also looking at low carbon natural insulation where possible, including wood fibre, blown fibre such as cellulose, hemp, etc. So I suppose the low carbon side is very much aligned with Passive House, even though Passive House is specifically energy standard and thermal comfort standard. So the same approach with Passive House, using the Passive House software, looking at materiality, looking at the carbon, I also apply on my retrofit projects. But the project with Robert, phase 2, was the first project with homegrown CLT. I had looked at CLT before, but earlier, say 15 years ago, it was all coming from Austria and Germany. So next slide. Yeah, so this is not talk about Passive House, but I suppose what I'm trying to clarify is that the principles of Passive House have been applied to the extension. So this is kind of consistent with most of my work. As I said, Passive House is a comfort and quality standard as well as an energy standard. It's not prescriptive about form, systems, or materials. Looking at a whole project, say from start, there are a hierarchy of design aspects that affect the energy performance, starting, in terms of impact, ultimately in terms of the energy performance. So say starting on the form and orientation, moving through for this facade, glazing ratios, shading, moving on to building fabric, and then finally services. So next slide, please. Sorry, next animation. Yeah, so sorry, go back a bit. Sorry. So what I would say about the retrofit or this particular project, it really was focusing on the sort of efficient form, compact form, using continuous super insulation. It shouldn't be draft-free, it should be draft-free construction, and also thermal bridge-free construction. So the focus is on fabric specification and construction, so these were applied without, I suppose, looking at the whole project using PHPP, which I would probably do now. This project started in 2019. There are also other standards that you could work to, such as LETI and also ACB standard as well. Next slide, please. Yeah, so I was appointed to the project in August 2019, back in those pre-COVID times, chiefly on the basis of achieving the statutory consents for the project through planning and building warrant. But obviously, based on my previous experience and the opportunity to work with a CLT system, homegrown CLT system, it was something I was really keen to do. Fairly consistent in terms of work that I was doing at the time in terms of extensions on 1920s, 1930s bungalows in Edinburgh, which account for quite a few of the properties in Edinburgh. Much maligned, but ultimately now fairly high value and extremely well constructed with large gardens. So definitely of interest for people looking to retrofit property and extend it. So that 3D there is the initial design sent through by Robert. Next slide, please, or next animation. Yeah, so really coming on board as an architect, it wasn't my job to sort of arbitrarily just change things to make it architectural as such. I did keep the notion of the extrusion, but the changes that I looked at were in terms of changing the orientation of the roof so that it would reduce the impact on the neighbour's garden in terms of shading. And so the next animation, please. Yeah, so the early concept did progress fairly quickly. I use Revit software, so it allowed me to go from that initial sketch through to a fairly sort of developed form and materiality fairly quickly. Next slide, please. So in terms of the planning process, I was appointed in 2019. The first submission was in January 2020. It was submitted on the basis of the elevations that are shown on the slide. So, planning came back fairly quickly. The principle of the modern design was supported, but they did note that, I'll just read the text, that bungalow extensions should be designed in a way that retains the character of the original, sorry, it's hiding behind my screen, the original property and the subservient appearance. So therefore, they felt that the overall extruded form with the gabled end was not in keeping with the bungalow. So at the time, that was fairly new, not legislation, but guidance on properties. And I suppose ultimately respecting the character of the bungalows, even though we were looking to reduce the height of it. So anyway, planning came back. They said that they weren't going to support it for approval. So we decided to withdraw the application, amend the design and resubmit. So the resubmission was free. It wasn't an additional fee on top of it. Next slide, please. So there was a process of consultation with the planner. The case officer was very accessible, very approachable, and it was a case of working through their objections, specifically the gable end proposal that was initially developed. So looking at a hipped end to the extension, that would, I suppose, keep it more in character with the adjacent bungalow. Also, the extension was pushed back from the face of the property. There was a discussion about the hipped ends, because obviously with the extension, due to the hipped ends, there was a decrease in internal floor area. So I was very keen to retain the hips at 45 degrees. The existing property has a lower pitched roof. So it was, through generating these 3D images, I was able to argue that, the pitch of the roof is not fundamentally important to the outcome. So planning generally came on board with the overall approach. And again, the use of Revit was a really valuable tool in terms of communicating the design as it's the different iterations of the design. Next slide, please. So the second planning submission was in August 2020, and external materials were also submitted. It was decided at an fairly early stage to use zinc cladding on the material because it's a non-combustible external finish. The actual this led to approval in October 2020, and it was generally a positive process. It's quite negative when planners come back to say you have to change the design, but I feel the work that was put in to change the design, to add the hips, actually generated quite an interesting solution architecturally. So it was positive, but there was an impact on form and the overall complexity of the build, however. Next slide, please. So this is, I suppose, one of the key stages in the overall process, and happened consecutively, with the planning design. So we were looking at the overall supply chain. Ecosystems were on board as a stakeholder fairly early on in the process, which allowed us to start looking at the overall construction with the CLT, the thickness of insulation, the detailing of certain aspects. A tricky detail was always the internal gutter, because obviously we couldn't project an external gutter over the boundary line. So from the start as well, looking at rigid wood fibre outer insulation was important in terms of the low carbon aims and moisture management aims of the construction. So from my perspective, wood fibre insulation or some sort of rigid insulation goes hand in hand with CLT. We also early on looked at the zinc cladding, working with a supplier in terms of looking at how the details could be resolved, particularly that slightly awkward gutter detail, as well as how you incorporate the ventilation. We also worked with a local or Scottish window supplier for the triple glazed windows, and also the slab with the insulated formwork, although it is EPS insulation, was deemed to be quite a good solution in terms of creating that sort of thermal bridge-free external envelope. Next animation, please. Yeah, so the overall development of the technology enables to achieve the continuous insulation that is stipulated by Passive House. There is the green ellipses indicate the thermal bridge-free design. So generally, you've got a good coverage of insulation at the key nodes in the construction, including at that gutter detail again. The junction between the wall and the insulated formwork is a good solution because you have the continuity of insulation, and the detail on the left, as you come closer to the existing building, is probably less favourable in terms of thermal bridging, but these interfaces are often quite hard to handle. Also, in terms of the vapour control layer, that is on the inside face of the CLT, as indicated with the red line. Next slide, please. Yeah, so the building warrants, the submission was in February 2021, so fairly quickly after that sort of technical resolution, the approval in July 2021. So a fairly normal process. I mean, there was nothing particularly unusual about this process for building control. They just view it as another extension, despite the, I suppose, technological aims of the project. Some of the key drivers for change, though, were looking at the kitchen, that because of legislation for accessibility, they wouldn't allow the kitchen to be in the extension, which is at a slightly lower level than the main floor level of the house. So we had to retain a residual kitchen within that area. Also looking at the internal spread of flame protection. So there is a coating that we're using, which achieves grade B internally on all timber work. Also, and this will be clear on the next slide with the sections, we're using an intermediate floor acoustic board on top of the nail lamp floor, and also the external wall cladding is non-combustible. Next slide, please. So in terms, I mean, it was designed to the building regs of the time. So at that time, with the U values, with a thickness of 160 millimeters wood fibre on the walls, we were achieving a U value of 0.21. On the roof, it is 220 millimeters of wood fibre, which achieves a U value of 0.17. So these are lower U values than would be the case now. So I suppose with a project such as this, you design according to the building regulations of the time, and there have been changes since then that would ultimately affect insulation thicknesses, etc. Next slide, please. So as Robert talked about, I suppose that sort of engagement with the supply chain continued through the building warrant process. It was a continuous process, it was consecutive, and so this notion of using data from other suppliers, the ecosystems were actually the certifier for the structural design, or they provided the information for it. So they provided information on the wall panels, interfaces, sorry, go back. Interfaces between the panels. They also looked at the fixing methods for the cladding and for the insulation, also provided information on the window. So this was all coordinated with the 3D model in Revit that had been developed. So next slide, please. So this ultimately led to for the fabrication process, which occurred in December 2021, only 3 months after the warrant approval. So that did obviously rely on the technical development and the supply chain engagement during that process. So quite a large overlap of activities through the design process, but ultimately that front loading does cut down in time and ends up with a better product. So the pictures there really just show you the range of phases of fabrication. You have on the left the slightly mucky insulated formwork for the foundation, which is effectively one of the few on-site operations. The 4 images to the right show the wall roof assemblies in what was in Best in Hamilton being fabricated. So the CLT with the wood fibre insulation, you have the roof windows installed, and also that gutter detail, which did take quite a lot of discussion, being resolved in the factory. So overall, a really positive process, and to be able to go to a factory and see everything fabricated before going to site as an architect is pretty much the holy grail. Next slide, please.
We might actually have to be a bit quick, Grigor.
Okay, that's fine. So this is the on-site assembly. Robert's covered this already. So as you can see, the panels being lifted into place on the roof with the zinc already pre-installed. And last slide. So that's just showing the range of internal finishes, which is ultimately, it's an engineering solution, but ultimately something that is quite beautiful. So that's me. Thank you very much.
Great, thank you. So yeah, we're going to hand over to Matt Stevenson.
Great. Thanks very much. I'm conscious of time. I'll try to nip through a few of the slides quicker than I might otherwise do, but great to be able to talk about this pivotal project in the journey that we've taken as ecosystems technologies. So I'll talk less about the technical delivery because that's been really well covered by Robert and Grigor. More about how this project fundamentally enabled as a living lab project, as ecosystems with our key stakeholders and partners to take forwards the homegrown mass timber agenda. So as ecosystems technologies, we design and manufacture beautiful timber buildings as a selection here. That is about us taking product from forest floor to finished buildings. I noticed a few questions about where the timber comes from. It's homegrown timber, so it's Scottish timber, and that's our whole raison d'etre, is to add value to that homegrown product. We're all about offsite manufacturing and how can we drive that efficiency, productivity, sustainability, and predictability that comes with that offsite approach. I'll not dwell on that just now. We take that homegrown product on this journey to finish buildings, but we do that by first producing engineered timber products. So that's cross-laminated, glue-laminated, nail-laminated timber, and other selected engineered products that we're developing. We create a set of building components, and those building components are where we drive replicability within our systems, and then those building components become constituent parts of our build systems. And because the replicability is at component level, it means that we can actually deliver those then into quite a diverse range of projects, and that includes new build and retrofit, volumetric and panelized. The materials, as a note, come from Scotland, predominantly from this northeast catchment area within Highland and Murray. We're based on our secondary manufacturing facilities in Invergordon, but we do the primary manufacture from the Homegrown Mass Timber Manufacturing Centre of Excellence at Best in Blantyre. The journey to add value to our homegrown product is a collaborative journey, and you can see here the sort of stakeholder map. So we have Best with their connected ecosystems and their centre for and destination for innovation. We've got Edinburgh Napier University with all of the requisite research and the fundamental building blocks that have been put in place in terms of understanding our homegrown timber species. We've got NMITE providing the sort of educational deliverables on that, and then what you can see here is ourselves, Ecosystems, described as a commercial accelerator. I'll talk more about that in a moment, but this whole journey is supported by the network effect of all these sort of invested stakeholders who want this to work. But critically, top right there, you can see customers and early adopters. Well, Robert's our ultimate early adopter, having put his money where his mouth is and delivered this project. And that has supported us to go on to take that product development, from homegrown product to enhanced build systems. And what you can see here, Robert's talked about this approach already, but the delivery of living lab projects is a fundamental part of this. So whilst we've been successful in securing £1.5 million as a collaborative set of partners to commercialize homegrown mass timber, through that funding was through Innovate UK, and that funding having provided us the ability to do structural, thermal, fire analysis through testing at Napier and University of Edinburgh. There's also post-occupancy evaluation requirement, and that's best fundamentally delivered through having living lab projects where we can actually put those products and systems into practice and yield the results. So I've described ourselves as a commercial accelerator. So that's us taking that knowledge, that pool of knowledge, and R&D and innovative capability from working with our partners, and putting that, creating an applied innovation environment for that. So that allows us to go very quickly from technical design to digital development, to full component prototyping. The living lab projects then becomes the bridge between that as a concept and a prototyped product, and the ability to roll that out for full scale manufacture. And it's in doing that full scale manufacturing commercialization that we can really deliver the environmental impact that we all aspire to. So if we take Howden Hall Road as one of our sort of incubator and sort of living lab projects, and demonstrate what that has delivered in terms of scale off the back of delivering that project. We have here, very quickly, and as Greg has expressed, the agility to be able to be doing the technical development, and then as soon as permissions are in place, roll straight into actual manufacturing, allowed us to be as agile as possible, develop as mature a set of details as possible for delivering this, and then to actually deliver it physically to site. Now, this project we've done quite a lot. We would have historically done a lot of volumetric build. This project allowed us to do two things: demonstrate a retrofit approach, but also a really enhanced panelized system, and being able to dial up both of those parts of our capability, was really tremendous through this project. What's important is the impact leading on from that. So that as a living lab project then has enabled us to roll forwards and deliver similar retrofit panelized solutions for school context and for commercial context. And I'll walk you through some of that. So delivering Howden Wells, the work for that was actually all the primary and secondary manufacturers done from the facility at Best, and it allowed us to really sort of work closely with Robert, with Grigor, to fine tune those manufacturing details. It meant, gave us the opportunity to apply the zinc. That was a new experience for us. Done a lot of timber cladding and a lot of more sort of familiar roofing materials. This allowed us to apply that zinc in factory. We wanted to minimize the amount of work that was residual to do on site, and it allowed us then to test drive installing. One of the comments asked about the craneage, where we used a HIAB, so a truck mounted crane, to install these panels. That allowed us to be pretty agile within the what was quite a constrained site in terms of access. and that install was done in the single day. The resulting project has both, great credibility in terms of it is aesthetically, obviously it's really striking, but the post occupancy evaluation work that Robert and the team have done has really made such a strong case study to be able to then talk to other clients about and present to other clients. Following on from that, I'll show you a couple of examples of retrofit projects, which there's a direct line of evolution from Howden Wells. So we worked with Hampshire County Council to develop a retrofit panelised system that is applied to a 1970s Scholar school. So Scholar schools, Hampshire 400 of these schools is something like 4,000 across the UK. The main contractor on site stripped away the external uninsulated single glazed facades, and we installed our pre-manufactured facade system in lieu of that, and that allowed for the transformation of this school into a high performance, the fundamentals of a new build. Skipping through this a little bit quickly to allow for questions at the end, but we followed up with that with the retrofit of the Scotland's National Retrofit Centre for BEST. So you can see here the original building is your typical sort of glass bowl, sort of goldfish bowl, overheating in the summer and excessively cold in the winter. And through working with a whole load of stakeholders, we've delivered a Enefit passive house facade replacement on that building. So really exciting to see then academic and a commercial sort of rollout. And it should note that although those are retrofit, and that's been exciting as part of this, is to demonstrate that these projects that we can do not just new build with high performance biogenic based build systems, but we can do the retrofit now. The good thing is there's crossover. As I said, common componentry means that as an example of this, working with DFE, we delivered the Gen 0 build system, which there's direct correlation between these two systems. So that ability to deliver into new build or retrofit scenarios is tremendously exciting. So conscious of allowing some time for questions, I'll finish there. Thank you.
Wow, thank you so much. Yes, we've had lots and lots of questions. The panel have also done a sterling job in answering a lot of them as we've gone along. So I might just, rather than actually ask any questions this second, I might just recap a couple of the things that have come up. There were quite a few questions about fire treatment, and I think the point was made that the OSB, for example, was SmartFly, who provide a fire-resistant board. The CLT had a surface spreader flame treatment to provide 60 minutes fire certification. I'm not sure if there's anything else you want to say about the fire treatment, but as I said, you've done a great job of answering those questions in the chat. Yeah. Also, quite a few, lots of comments rather than questions about, I think, using homegrown. I think lots of people were very interested to find out about ecosystems, asking about whether you're just Scotland alone, and you made it very clear, Matt, I think, that you operate UK wide.
Yeah.
There was an interesting question which you answered, Robert, about whether there's anything you would do differently, and you mentioned glazing. I don't know if you want to say anything out loud about that.
Yeah, sure. I mean, I think we started the journey in 2011, and the first iteration of that phase one. I think we probably dialed it back with the cantilever extension. I mean, it is amazing in terms of what it does in terms of flooding the building with light. It is elevated off the ground, but I think we probably dialed it back to get an uplift in overall sort of fabric performance, more for thermal comfort during the winter period. I mean, as I say, it's not. I wouldn't say it's a mega issue, but I think where we're at now and what we know, we've probably dialed that back, and you can see how that plays out into phase two in many respects. But it's a living lab, it's a learning journey in many respects. But equally the solar gain you get because it's southwest facing, and the daylight factor that you get is exceptional and it doesn't overheat. But yeah, as I say, there's positives and negatives, but I think in the round we'd probably dialed some of that back.
Actually, as you just mentioned, the cantilevers, I didn't quite catch what the Okoya beams were actually being supported by. There were some little feet, I think, that you showed in the.
They were simply
animation.
dial gauge. No, they're dial gauges, so that was just simply to measure deflection. I mean, they were removed. Those, yeah, that was just something that we did at the time from an experimental basis to correlate the deflection of them, the instantaneous deflection as loaded up, i.e., installing the windows, and then to look at performance over time, in terms of what you call creep, so how much the timber would move over a period of time due to weather conditions, etc. But they were ultimately removed, and deflection wasn't a problem at all. So they are cantilever beams out that go back under the building and are pinned to the underbuilding.
Great. One thing I was wondering about, it's great to see a project, and particularly to be able to see the costs involved, and thank you very much for being so candid and showing all the costs involved. How easy do you think, how sort of replicable would this be for somebody who wasn't, say, plugged into the networks that you're plugged into, that you have access to, in terms of reuse and using homegrown? What do you think?
I think using the homegrown is completely achievable. Agreed, the networks that I'm involved with have absolutely facilitated the delivery of it. Obviously, the techniques that are used, particularly the offsite, high level pre-manufactured value add, isn't always available, particularly of projects of that size. But I think, as Matt showed as well, what it's certainly informed is future iterations. And now Matt and Ecosystems as an operator, have a series of options that they can deliver into the market at all different scales. Matt, I don't know if you wish to comment on that.
Yeah, no, I mean, I think the value of what you've done, prior to you doing this, the barriers to somebody sort of accessing a solution like this would have been greater. This project serves to reduce those barriers because there's a technical, demonstrable sort of solution, and you've essentially sort of de-risked and made more accessible that process for others. So I think that it's one of the great byproducts of that living lab approach.
Great. I just saw somebody had dropped in a question asking if anybody can say a bit more about air tightness and the VCL. Sure. There are also a couple of other questions, I think, earlier on about ventilation, and I think somebody mentioned that you're using a trickle ventilation there. But just if anybody would like to say anything more about air tightness.
Yeah, if it's helpful, I can talk about the approach which we've taken with this. So in this delivery of our sort of panelized approach, we've relied on the CLT to provide the air tightness and essentially the vapor control layer. The timber is hygroscopic, so it can absorb and release moisture, and it's got good thermal mass, so it does similarly with any excess heat. It's because of the 3 layers of glue. What we do find is that we achieve we can achieve passive house levels of air tightness. Our projects where we haven't applied a separate air tightness layer as such have achieved sub 0.6 air changes per hour. That said, the project for the Scotland's National Retrofit Centre did have an external airtight membrane applied for it for absolute belt and braces, particularly because it was the Enefit Passive House Enefit certified project. So, but it is one of the good good aspects of the CLT, it will achieve that. I guess to complement that, the use of either solid wood fibre insulation or indeed warm cell, the blown in cellulose, which we use routinely. Those are both demonstrably good at improving airtightness performance, and there's good. I know PYC have done testing that demonstrates an uplift in that airtightness performance. So whilst we'll rely on the CLT, we've got that additional benefit in our systems. We like to minimise the amount of layers where we can, whilst not compromising the performance.
Thank you. I suppose one last question. Obviously, you had to go back to an extent to the drawing board in terms of planning, but it looked like building control was fairly unproblematic. Was that the case?
Yes, I mean it was a fairly regular extension, to be honest. I mean they didn't really bring up anything about the CLT. We provided information on the surface coatings when we submitted, so nothing unusual came back. It was only really the kitchen that was the tricky part, which is nothing to do with the engineering solution, but the fact that they wanted the main kitchen to be on the main living level. So obviously that's something that Robert has now resolved, but at the time it did call for a bit of sort of layout change to the project. But otherwise, really straightforward process, which it usually is. I mean, building control don't usually throw up things. They're usually pretty well informed about current technologies, and so they tend to work with you quite positively.
Brilliant. Well, yeah, I think we've certainly covered a heck of a lot over the last hour, and it's been a fascinating webinar. So thanks to all three of our panel. I'm just literally, before we end, I'm just going to briefly tell you a little bit about our next designTimber webinar. There you can see the full list of our upcoming program. But the very next one is the Urban Nature Project at the Natural History Museum. Field and Fowles Architects, Xylotech and Engineers HRW. This was the Gold Award winner at the recent Wood Awards. You can see from the pictures what a fantastic project it is. But if you'd like to join us for that one, that will be Wednesday, the 11th of February. But yeah, once more, I will just say thank you very much to our amazing panelists, and to our audience, have a great afternoon. Thank you. Bye.
Thank you.
Excellent. Thank you.